Class 10 Chemistry, Chapter 2 Chemical Bonding. In the previous class, we have already learned about why atoms form bonds and how is it formed. And we also learned about the electronic configuration of elements. We also learned about the noble gases and their electronic configuration. And we also learned about the octet rule. And in light of this octet rule, in 1916, Cosell and Lewis developed the electronic theory of valency. And according to this theory, atoms combine so that they can occur the nearest noble gas electronic configuration. They do so by losing, gaining, or sharing electrons. This leads to the formation of chemical bonds between the combining atoms. We know that a chemical bond is the force of attraction between two combining atoms. There are three common types of chemical bonds. When atoms combine, there are different types of bonds. They form different types of bonds. First, we have electrovalent or ionic bond. Second, we have covalent bond. Third, coordinate bond. And in today's class, we learn about electrovalent or ionic bond. Elements can be divided into two. We know that elements can be generally divided into metals and non-metals. Metals, first we have metals or electropositive elements. Metals or electropositive elements whose atoms readily give up or lose electrons. In class 9, we have already learned that metals, they usually lose electron in order to be stable. Examples of metals or electropositive elements are sodium, Na, calcium, Ca, lithium, etc. 2. Non-metals or electronegative elements. We know that non-metals or electronegative elements, they gain electrons so that they can be stable. Examples of non-metals elements are oxygen, chlorine, nitrogen, etc. An ionic or electrovalent bond is formed when an electropositive element combines with an electronegative element. When we say an ionic, it means ions. When elements lose or gain electrons, they become ions. In class 9, we have already learned about ions. And we also learned about cations and anions. And in this picture, we can see that sodium is a metal and chlorine is a non-metal. When sodium and chlorine combines, sodium loses one electron and chlorine gains one electron. And in this picture, we have a sodium atom, element sodium. Atomic number is 11. From this picture, we can see that in the first shell, we have 2 electrons, and the second shell, we have 8 electrons, and in the third shell, we have 1 electron. We can see that the first shell is also complete, the second shell is also complete, but the third shell is incomplete. And what this element sodium can do is, it can lose electron in order to be stable. We know that for an element to be stable, it needs to have 8 electrons in the outermost shell. And in this case, sodium has only 1 electron. What it can do is, it can lose 1 electron. Here we have sodium, the element sodium. When this sodium loses 1 electron, it becomes positively charged. First, we have the sodium atom. It has 8 electrons in the second shell, 2 electrons in the first shell, and only 1 electron in the outermost or valence shell. When it loses 1 electron, the sodium atom becomes sodium ion. It is now stable. It has 2 electrons in the first shell, and in the second shell, it has 8 electrons. It has already acquired the stable electronic configuration. Electronic configuration 287, chlorine, atomic number 17. Now let's see for chlorine. It is a non-metal. Electronic configuration is 287. It is only 1 electron short of the stable inert gas configuration of argon, 288. We can see that chlorine, the electronic configuration is 287. That means it needs only 1 more electrons to be stable. If it gets 1 more electrons, it will now be just like argon. We know that the electronic configuration of argon, which is a noble gas, is 288. Chlorine atoms tends to react and gain electrons. That is, they are electronegative. For chlorine atoms, instead of losing electrons, for chlorine to gain electrons will be easier since it needs only 1 more electrons. By gaining 1 electron, electrically neutral chlorine atoms becomes a chloride ion with a net charge of 1 negative. When chlorine gains 1 electrons, it becomes negatively charged. Here we can see that first we have a chlorine atom, electronic configuration 287. When it gains 1 electrons, it becomes negatively charged. And the outermost shell now has 8 electrons. That means it is now stable. Chlorine is now negatively charged. It becomes a chloride ion. When sodium and chlorine react together, the outer electron of the sodium atom is transferred to the chlorine atom to produce sodium ion, sodium and chloride ion. We know that when sodium and chlorine combines together, we know that sodium is a metal, it is electropositive. Chlorine, it is a electronegative. Sodium loses electron. Sodium needs to lose 1 electron in order to be stable, and chlorine needs to gain 1 electron in order to be stable. So when sodium and chlorine combines, the electron which sodium needs to lose is taken by chlorine, and then both become ions. Now sodium is also stable and chlorine is also stable, and now they readily form a compound called sodium chloride. The two ions being oppositely charged are now held together by the electrostatic force of attraction. We also know that unlike charges attract each other and like charges repel each other. Just like that, sodium and chlorine are unlike charges. Sodium is positively charged and chlorine is negatively charged. That is why they are held together by the electrostatic force of attraction, or a chemical bond. Since both sorts of atoms attain a very stable inert gas configuration, the process is energetically favorable and the compound sodium chloride is formed readily. From this picture, we can see that sodium, it has 1 electron in the outermost shell, and chlorine, it has 7. Sodium needs to lose 1 and chlorine needs to gain 1. When the electron in the outermost shell of sodium is passed or given to chlorine, sodium becomes stable and chlorine also becomes stable, and they combine and they form sodium chloride, and now both are stable. In a similar way, an atom of magnesium combines with 2 atoms of chlorine to form magnesium chloride. Magnesium, the electronic configuration is 282 and chlorine 287. Here we can see that magnesium needs to lose 2 electrons in order to be stable, and chlorine needs to gain 1 electrons. And here we have 2 chlorines. The 2 electrons in the outermost shell of magnesium is taken by 2 atoms of chlorine. 1 electron is taken by 1 chlorine atom, and the other electron from magnesium is taken by another atom of chlorine. And here they can form magnesium chloride. Calcium and oxygen atoms combine to form calcium oxide. In a similar way, calcium and oxygen also combines to form calcium oxide. We find that the stable structures like that of the noble gases is attained by combining atoms, by the transfer of 1 or more electrons from one atom to another. From the previous examples, we can see that electrovalent or ionic bond is formed by the transfer of electrons, 1 or more electrons, to another atoms, which needs electron in order to be stable. Thus, we can define electrovalent or ionic bond as the type of combination between atoms which depend upon the transfer of electrons and in which oppositely charged ions are held together by electrostatic force of attraction. The number of electrons lost or gained by an atom to attain the stable electronic configuration is known as the electrovalency of the atom. From the previous examples, we can see that different atoms needs to lose or gain different numbers of electrons. And these electrons, the electrons which are lost or gained by an atom to attain the stable electronic configuration, that is to have 8 electrons in the outermost shell. Those electrons are known as the electrovalency of the atom, the number of electrons they need in order to be stable, to lose or to gain. That is known as the electrovalency of the atom. And the compounds formed by electrovalent or ionic bonds are called electrovalent or ionic compounds. In the previous examples, we know that sodium and chloride, they combine to form a compound. And this type of compound formed by ions, like sodium is also an ion, chlorine is also an ion. Sodium is a cation and chlorine is an anion. When they combine, they form a compound. And this type of compounds formed by ionic bonds are known as ionic compounds. And for your home assignment, question number 1, what is an electrovalent bond and how is it formed? State at least 3 conditions for the formation of ionic bonds. What kind of elements form cation? Give 1 example. For what kind of elements form an ion? Give 1 example. 5. Why do most of the elements form ions?